Yeah, good morning, students. Today we shall see about the different instructions available in 8051. So we will see it under different categories so that it is very easy for you to write programs. So basically, we start with data transfer because we need to know from where we need to take data, and then we go on to the arithmetic operations, logical operations, boolean, and then branch instructions. So we shall have an overview. After that, when we go into examples, we shall see about the detailed examples uh, of how to use those instructions. You can always refer the Intel manual. Okay, so first thing is the data transfer. So basically we should know from where to where the data moves. Okay, so you have move instructions, and it is to move the data to a register or from a register to another register, or to a memory, or from one memory to another memory. So for that you have few instructions. When you say move, so what are the operands? It could be a comma hash include some value. Okay, so the first one could be immediate addressing mode. Then we have move C, which we did with indexed addressing mode. Move X we did with indirect addressing mode. So all the first three is just to move data through a register or through a memory. Then you have push and pop, which are meant for stack. We will go into details when we see about the stack. Then you have XCH and XCHD. This is to exchange data between registers. And then arithmetic and logic, basically we have all the add, subtract, increment, multiply, divide, all that also we shall see in detail. Then what are the logical operations? We have AND operation, OR operation, XOR operation. Then you have complement operations, rotate. You can rotate it to the right, to the left, to the with the carry and without the carry. You can also swap. You can swap between digits. For example, if a value is 45, I can make it 54. Just swapping, right? And then we have Boolean instructions. What do you mean by Boolean instructions? So Boolean means it is ones and zeros. So it is just working with one bit, right? So when I say clear, I can just give clear any bit. So in the memory space, we have bit addressable locations. So for our best understanding, carry flag is a bit, parity flag is a bit. So you can always give clear C, that means the carry flag is cleared. When you say set B and you mention a bit, it could be a port, pin, whatever it is. You can always give set B. Okay, and you can also have move bit, which we don't use, and then you have the AND operation, the jump on bit. All that is working with one bit value. So all that can be used using this boolean. Next we go on to branch instructions. So this is for the change of the program control from one area to another area. So you call it as branching. So in branching you have different types. So you have jump, and in that you have L jump, S jump, A jump. So this is just to indicate that the program can go to another area within a memory limit. That we call it as short jump, long jump, and absolute jump. Okay, so that difference comes only in the memory area where it will be jumping. If I say L jump, it means it can go to any area within the 64K memory, right? So that is the only difference. Then you have some conditional jumps. So the first one is just ordinary jumps. Then we have conditional jumps. So you have jump JZ, that means it will jump if the zero flag is set. JNZ means it will jump if the zero flag is not set. Then you have compare and jump if it is not equal to. If there are two values and they are not equal, we can it will do a jump operation. And then it will decrement and jump if it is non-zero, that is it will decrement a register, check if it is zero, if non-zero it will jump. Then you have call and return, which we will see in detail when we go into subroutines or into interrupts. So let us just start with an example. so that you will get an idea. After that, you have to explore each instruction and see where you can use it. If you just go on explaining every instruction, you will just read it as theory. So let us work out one simple example. Okay, so I will guide you step by step. So here the program is to add 2 bytes and to store it as a 16-bit value. Okay, so when we do the addition here, basically it is only a 8-bit addition, but it is told that we have to do a 16-bit result. So then what do we do? So we shall see how to do. So I'm assuming that the values are in locations. I'm taking two locations, 4500 and 4501. So first thing what I need to do, I have to initialize it to a pointer. So as we saw, this data pointer dptr is the pointer. So I assign it a location which the location which I'm using, which is 4500. Now from that location I move the value to A. It is an indirect way of addressing. And that value I move it to B. If I say move B comma A, it is just moving between registers. Then now I increment the DPTR. Incrementing DPTR means the data pointer is now pointing to 4501. Now I add both. And the added result I put it into again A. Sorry, the result is in A. I move it to the DPTR. Okay, so it is nothing but I move it to the memory location, and now I increment again DPTR, and I'm checking if there is a carry. That is, I have added two values, but the question is I should store a 16-bit result. So if there is a carry, I will store the next byte as 01. If not, I will store it as 00. So I'm checking for carry. Carry means it has crossed 8 bits. So if there is a carry, I go to L1. So this is a conditional jump. So it is checking for carry and it is going to L1. There I am moving 01 to the data pointer, that is to the memory, and I am stopping. There is no halt instruction. So I stopped in the same location, right? If not, I am moving 00 and I am moving it to the location, and again it is stopped. So it's you start writing on your own so that you will understand what are the different instructions you need to use. So we shall work out after I explain you for few more examples. So rotate I gave you, but it is not so easily understandable, so I am giving you with the example. So for example, I have a value of 52. So write it down as an 8-bit value, 5 and 2. Now I am rotating it to the right. Okay, so you have a rotate and you have a rotate with carry. So what is the difference? So when I say rotate with without carry, so what I do is I just move one bit to the right. So this 101 is 5. So when you just shift one position, the last bit, that is when I move to the right, it is the D0 bit that goes inside carry flag. So 1 goes to the carry flag. But whatever is in carry flag doesn't come here. We just move it, and here I insert a 0. So this is the result value which I will be getting. So I get it as 29. When I am taking the second example where I use a carry flag. It is RRC. In that case, I have to see what is in carry flag. For example, I have 1. In that case, what happens is carry flag comes to the last bit, and this is the last bit is moved into carry. So that is the only difference. So now the value which I get is A9. Okay, so you try to work this program at home. So this is to find out if the A register is odd or even. If it is odd, you have to store 01. If it is even, you have to store 00. Sorry, even you have to store 01, odd you have to store 0 0. So what logic will you apply? You could use any logic, but the simplest one what I will say is you can just rotate it and check for the last bit. So the last bit, if it is 1, that means it is a odd number. So try it out. So I will teach you how to write delay programs. So basically, how do you write a delay program? So delay program is nothing but you just have to spend some time. So we are not going to find out how the timing is maintained, that is 1 second or 10 milliseconds. I'm not going to do that now, but I will just teach you how to write a delay program. So this is the flow. You need to load a value, you have to decrement it. So it is similar to counting. For example, I just keep counting till 51, 2, 3, 4 till 50. That means I've spent some time. Similarly, in the program, what I do is I load a value, I keep decrementing it till it becomes 0. That is the only thing I do. So this is the best example. So I have given one value into R2 register. I just keep decrementing, checking, then again I'm just in that loop. So if I have to have another loop, I will have 2 registers being loaded and keep decrementing. So now if you take the second half, that is under nested loops, it is doing 5 times FF, right? FF is reduced to 0, then 5 is reduced to 4, then again FF is taken. So much time delay we are able to get. So we shall try out few programs now. Okay.